Hello everyone. In this video, we will study the sixth problem of AtCoder beginner contest 350. Here we have a string and here are three rules. First rule. The first rule is delete the parentheses. And the second rule is to change the lowercase to uppercase and change uppercase to lowercase. And the last rule is to reverse the string order. Reverse the characters between the parentheses. Okay, now let's see the sample. In the first sample, here is the first parentheses. So we delete the parentheses and we change the uppercase of A to lowercase a. Because here is only one character, we don't need to reverse. Now it becomes like this. And for the second step, we delete the parentheses and then we need to change AY of lowercase to uppercase AY, and we need to reverse the order, so it's YAX. Okay, so this is the answer. Now we see the second sample. Okay, here we can delete the parentheses, so to change the uppercase to lowercase and reverse the characters. And n is unchanged. And here X set and Y we need to change Y to uppercase. Okay, this is the first step, and the second step we can deal with the inner parentheses. X, Y set with the uppercase to change to lowercase and to reverse the order. Set Y X. Okay. The final step, delete the parentheses and change the order and change the lowercase to uppercase. So here we get the answer. Okay. Okay, now we want to know when to change the case. For example, XY set, well, we need to change it to XY set with a lowercase or unchanged. Okay, we can count the number of parentheses. This is the first parentheses, and this is the second parentheses. Change and change again, so the uppercase unchanged. Okay, and now we calculate this Y, the first parenthesis and the second parenthesis, the third parenthesis. Because the count of parentheses is odd, we need to change. If the count of parentheses is even, we don't need to change. Okay, if count change, okay, si, this means the letter is changed, else do nothing, we don't need to change. Okay, now let's study the reverse rule. For example, A, B, C, and D. Okay, if we at first we traverse the string from left to right, and we will met the left parentheses before right parentheses. If we meet the left parentheses, we need to traverse from right to left. Okay, for example, this is the second position, the first, second, 3, 4, 5, 6, and we need to find the counterpart position of the parentheses. Here, match 2 is 1, 2, 3, 4, 1, 2, 3, 4, 5. This means a left parenthesis in position 2 and the counterpart right parenthesis is in position 5. Okay, so match 5 is 2. The big position is the right parenthesis, and the smaller position is the left parenthesis. Okay, and here, so if we meet the left parenthesis, we can reverse from 4 to 3. Match I minus 1. This is the right end of the position, and 2 I plus 1. Okay, and this order is from right to left. Okay, now we can take another sample, something like this: A, B, C, D, E, F, something like this. At first, we meet left parenthesis, so we traverse from E position. 1, 2, 3, 4, 5, 6, 7, 8. 8. 1, 2, 4, 5. Okay, and then the next time we meet the right parenthesis, we need to traverse the string from C to D. C, this is the index is 7, and the match 7 is 4. So we need to traverse from match I. Here match 7 is 4 plus 1, 2 I minus 1, and the order is from left to right. Now we can code according to this idea. Using namespace std int main. Okay, 500,000, and we need a match array and an input to train as the length of S. If we want to start from the position 1, we can add some character before the string. I increase, and if SI is left parentheses, and we need to use a stack to store the position of the left parentheses, sta. So sta push the position, and else if this is the right parentheses, pop. Okay, and finally, this case include the characters. If the count of parentheses is odd, we need to change the characters. And here, match top, and here I is the index of right parentheses, and stack.top is the index of the left parentheses. Okay. Now we compile first. It's okay, and we can here the left position and the right position and the direction. Void dfs int arrow left, the leftmost position and the rightmost position and the direction. So we can use enumerate from left to right, and the opposite is from right to left. Okay, so we search the direction. Okay, this is the opposite order, and from left to right, it's possible for us to meet the left parentheses. So if si now we need to reverse the order. here I plus 1, no, I plus 1, and the right I is the position of left parentheses, and the match I is the position of right parentheses. From R to L, okay, and these two parameters don't include the position of parentheses, okay. So here and this is the odd. When the when the traverse is finished, and I can go here, then I plus I increased and to the next position. So we don't need to deal with the right parentheses because this is the position of the right parentheses, okay, and else only include the characters, not include the right parentheses. Here, else if it's the character, we can output the character directly si, okay. Now the logic from right to left is similar. We may meet the right parentheses before the left parentheses if si is the right parentheses. Okay, so we go here, and here we need to change. So this is the match I position. BFS match I. Match I is the left parentheses index, and I is the right parentheses index, and this is from left to R. Okay, and I is when these characters is finished and the index go here, then decrease and we'll move left one step, okay. Else output si. Now let's test. This is the second case. Wow. Okay, something wrong happened. It seems okay. From R to L. Direction. Okay. This is the first sample. And let's debug. Okay. It's okay. And the first is left parentheses. So this is 2 to 5. Okay, 2 to 5. R is 5. Okay, and oh, this one is the right parentheses. Okay, now test again. It's okay, and for the second case, is correct. Yeah. Submit. Here we use stack because stack is convenient for dealing with the parentheses. And here is a recursive function. And here change the order. Okay, the solution has been accepted. So our task is finished now, and see you next time.